In this example, we're looking at, again, a type of geometric question. So it's very similar to what we looked at in the first section of chapter 2, but in that section we were really constructing out of what we knew, so O to A or O to B, and then like labelling them A, B, C, etc. Here we're actually going to use the I, J's and K's to help us out. So I'll use a similar method. So first thing, we've got O to A. I'm going to make that blue. So that's, use the line tool, the arrow. So O to A is that vector there. So I'm just going to make that a blue one. So I remember green for O to B, and I'm going to make the O to C purple. So there, O to C. So you can see going in the 3 perpendicular directions there, and I'll just label them too. So if you don't have colours, obviously you would be labelling them. So this would be O to B, which would be 5J, O to A, which is 3I, and O to C, which is 4K. So in the 3 directions, I, J, K. Now the first question here, A, is asking us, find in terms of I, J and K, find the vector D to B. So if we think about actually drawing that vector D to B, there's D to B, you can see straight away it's the opposite of the light blue vector that you've got there. So it's the opposite, so the negative of O to A. And we know what O to A is, it's 3I, so this would be negative 3I. Okay, it's just this vector picked up and then flipped around with a negative. For the second part, and that's I, that's part 1. Part 2, we've got O to D. So again, I'm just going to draw O to D so we can see it. So there's O to D. Now we can get there a couple of ways, but probably the easiest way is to go along O to A here, okay, which we know would be 3I, and then go along this direction, which you can see is the same as that vector there, O to B. Remember, I'm going tail to head, so you can see that that other vector would be O to B. And actually, let me just write that out slightly differently, so you can see it's O to A plus O to B. O to A is 3I, O to B is 5J. So that would be your vector from O to D. Okay, 3I plus 5J. The next one, 3, we've got D to F. And looking at our diagram, I'm just going to get rid of the vectors that I've drawn there. D to F is going from this point here up, and you can see straight away that's exactly the same as the purple vector, O to C. So it's literally going to be just 4K. Oops. Okay, the last one in that section, IV, 4, is O to F. So now using your vectors again, and just drawing it on your picture, and it's always a great idea to draw them in instead of trying to do it in your head. It can be quite hard doing it in your head. You can see going from one corner of the box to the other corner of the box, you'd have to move around the edges. Go from the tail, okay, to the head. And you can see here you'd have to go along the blue vector, so it'd be OA. You'd have to then go across from A to D, and then you'd also have to go up from D to M. Okay, and we know what those vectors are equivalent to. AD is equivalent to OB. You can see they're the same, and DM is equivalent to OC. So we literally then just chuck everything in. I, 5J, and OC is 4K. So that's how we get from O to F, coming around here using all the vector quantities that we already know. For B, we're asked to find the magnitude of OF. Remember that for the magnitude, we take the square root of all the parts in front of I, J, and K, and we square them. So we'd have the square root of 9 plus 25 plus 16, okay, which is the square root of 50, if you add them all together. And the square root of 50, in terms of what will go into here, you've got 25 times 2. Square root of 25 is 5, square root of 2 is still root 2. So the magnitude of O to F is 5 root 2. Okay. The last part here is a little bit trickier. So we're asked to find midpoint or measurements to this midpoint M. So I'm just going to delete what we have on here. So the first one's asking us to find the midpoint going from the origin to the midpoint M, which is halfway between F and G. So it's this vector here. So again, I'm going to construct that using what I know. And what I might do, I'll just get rid of these parts here. Oops. So we've got a bit of room. Okay. So we can see here that we're going from O to M. We'd have to go across this way. So A to D. So I'll just write this down. We're going from O to M. We'd go AD. We'd then go up D to M, or D to F. And then we would go along for that last part from F to M, across there. So now we just have to think about what those vectors are in terms of things we know. AD you can see is exactly the same as the green vector, so it's simply OB. OF, okay, so thinking about this is DF, should make that a bit clearer. DF is the same as the purple vector, same direction, same height, so that's the same as OC. FM, this vector here, remember that this vector going along here, this side length, O to A, okay, is the blue one. This is actually going backwards, so it would be negative O to A, but it's also only half the size of O to A, so it's a half of O to A. So we're going backwards along this vector, but only halfway along, so that's why it's only half of OA. So now we can put everything together. OB we know is 5J, OC we know is 5K, or 4K, and then we've got negative a half of O to A, which is 3I. So our final vector for O to M would be, and I always just put it in IJK order so it looks, you know, consistent, negative 3 over 2I plus 5J plus 4K. So that's your O to M vector. Okay. Cool. The next thing that we want to look at to finish off here is going to be O to M's magnitude. And again, I'll just get rid of this section here. Got a bit more room. Okay, so magnitude O to M equals the square root of, and then all we have to do is take what's in front of the I, square it, what's in front of the J, square it, and what's in front of the K, and square it. Now this is a little bit sort of slightly ugly in the sense that we're now going to get 9 over 4 plus 25 plus 16. Okay, now a nice way of doing this, if you want to work with something like that, is to make everything over the same denominator. So I'm actually going to make everything here over 4. So 4 times 25 is 100, and 4 times 16 is 64. I'm going to make everything here over 4, so it's a bit more consistent. Now this is the same as saying, and again I'll just get rid of this part here, this is the same as having the square root of 9 plus 100 plus 64 over the square root of 4. So all we've done there is just split this up, and I'll just make sure you can see there that that's where the square root is, square root of the whole thing. So now square root of 4 is 2, so there's a half, okay, outside of the square root of this altogether, and this is going to be 173, so it will be square root of 173. Leave it in exact form. So don't take it to a decimal because you're not asked to do that in the question, so leave it exactly in surds. So the length of O to M is a half of the square root of 173.